Welcome to the last week of class. This week we're talking about chapter 11, functions. Okay, this is kind of a dense chapter. We're going to draw on a lot of ideas from different chapters and kind of cram them all into one. So there's a lot to cover this week. The question we want to answer is initially just what is a function and how is it different from an equation? Okay, we've been dealing with equations, but how is it different? How are functions different from equations? The answer is that functions are equations, but they're a specific class of equations. So all functions are equations, but not all equations are functions. Specifically, functions are equations that only have one answer for a given input. So if I have an x value, it only has one y value. We'll see some cases where that's not the case later, but so for the most part, this is what we have dealt with, but there are some cases where that's not the case. So an example, let's say we've got zip code, and our output is town. This is a function. For a given zip code, it corresponds to a single town, okay? The reverse of this may not be true. Okay, so this we'll talk a little bit about this later. That's what we call something else. But right, if our input was town, our output was zip code, we would not necessarily have one output in that case. Okay, so just because we have a function where our input and our input leads to one output doesn't mean that the opposite of that is true. Again, we'll talk about that a little later. Another example, let's say we have the equation x equals y. Got the input and output. Our input is x, our output is y. So input is 1, output is 1, input is 2, output is 2. For a single x value, we get a single y value. This is a function. Okay. Another example, the area of a rectangle is our input, and we want to know, and our output is the width of a rectangle. Okay, this is not a function. Okay, there are many different possible widths which would satisfy the area of the rectangle. Okay, so that's not a function. However, there is an equation. So, okay, so here's an example. Looking at a given set of points, can the following points be described by a function? So here's our collection of points. Just take a look at those for a few seconds. And you should see that the answer is no. This is not a function. We've got 2 points right here. Both have the same x value, but they have 2 different y values. So this is not a function. Okay, so this leads us to what is known as the vertical line test for functions. Okay? And basically what this says is that if any horizontal line will cross, I've got horizontal line, that should be, that should be vertical line. If any vertical line will cross the graph 2 times, it is not a function. Okay? So an example, here's y equals x squared, and we see that I can't draw a horizontal line anywhere and have it cross the graph in more than one place. Okay? So this is a function. This is a graph of a circle, so this is where, so we won't look at what this equation is, but we see that if I draw a horizontal line here, or pretty much any place in the region of this circle, we'll cross the line more than one time. So this is not a function, but again, there is an equation for this. Okay, so hopefully you have a good idea now of what is and is not a function. They're fairly easy to determine when you graph them out. It can be a little bit more tricky when you're actually looking at the equations, but it should become fairly easy for you to determine what is and is not a function. Okay, so now let's look at graphing functions. We've really done this in the past in previous weeks, but now we're going to look at different types of graphs and how we can manipulate those graphs. So here's an equation that we haven't graphed before. Y equals the square root of x. Always a good way to graph any graph for your first time is just to plug in the numbers. So, pick a handful of points. I'm going to do that. So we've got 0, 0. So the square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. And then draw a line that connects them. Let's look at another equation. Y equals the square root of positive 3, x plus 3. And we see that we get a second curve that looks just like that first curve, but it's shifted to the left by 3 units. Again, so all we did here is just plug in numbers and got out some values and connected the line. So you do that for more complicated graphs. We don't need to go into, doing that a million different times. There's lots of techniques to make this simpler, but just, for this class, let's just stick with the plug in numbers and get out values and draw a line that connects them. Okay, now we sort of hinted at it in that last problem, but we want to look at how we can transform graphs, how we can shift them, rotate them, invert them, things like that. So in that last problem, we looked at how we could shift a graph. Let's look at it more concretely. To shift a graph to the right by a units, we want to substitute for x the value x minus a here, okay? So any place we see an x in our equation, we want to replace it with x minus a to shift our graph to the right. To shift the graph to the left, we substitute an x plus a here, okay? So let's look at an example. Here we've got y equals x squared. So we've got this graph that we're fairly comfortable with at this point. Let's look at another graph, y equals x minus 2. And what we see is that we've shifted our graph to the right by 2 units, okay? What's very important when you're doing this is to make sure you include parentheses. Just that way you don't accidentally confuse, adding 2 units to the entire graph versus, replacing that x. So those parentheses that we've got here, they are very important. So make sure you include that when you do these. Okay, next we want to shift our graph to the left 3 units, and we see that our equation can be replaced by x plus 3 squared. Okay, so we've taken the exact same graph and we've just shifted it to the right and to the left. Very simple. Okay, let's continue this discussion. How we want to shift our graph up by a units. So to do this, we add a to a y, okay? So, example, let's say we've got the equation y equals x squared. If we add 2 units, if we add 2 to y, so we go from y equals x squared to y equals x squared plus 2. Notice this is not, we're not replacing x with x plus 2. We're adding it to the end. We're just adding it to y. And we see that this shifts up our graph. This one should be fairly, intuitive to you. I know that last one, the sign was opposite, so that's something you want to keep in mind. And we can similarly subtract 3 to shift our graph down by 3 units. Okay, so hopefully this one should seem fairly intuitive to you. Okay, this one is going to be probably the least intuitive if we want to stretch and shrink a graph. Okay, so if we want to stretch a graph, we multiply every point by a fraction. Okay, what do I mean by this? Let me just show you concretely. Again, just starting with an equation, x squared plus 1. That's, my apologies. That should be x plus 1 squared, like that. Okay, and we've got this parabola shifted to the left by 1 unit. I just kept doing this. Sorry about that. Okay, so now if I multiply that entire graph, that entire equation, so here I had this equation, if I multiply the entire thing by a 1/2, I get a graph that's about twice as wide as the previous one. Okay, so that's counterintuitive, right? Maybe you'd think initially that if you multiplied it by a half a number, it would get narrower. But just remember, plug in values and it'll sort of lead you to this. But basically what we're going to do is we're going to drop each value down to half of its initial unit. So that's going to make it much wider. Okay? Again, let's do the same thing here with me correcting my typing mistake. And there we go. And what we see here is we get a narrower. We add a 2 out in front, and we get a much narrower graph here. Okay? So this is stretching and shrinking. That's probably going to be, like I said, less intuitive, so make sure you do some problems associated with this to get yourself really comfortable with this idea. So again, bigger number equals narrower graph. Okay, so now if we want to take a graph and reflect it about the x-axis, all we do here is multiply every number by -1, right? If we have a parabola that's all above the axis and we want to make it all below the axis, we just multiply everything by -1. Again, let's just concretely, here we've got x squared is above the axis, negative x squared is all below the axis. We can just reflect it. Very simple. This one should be somewhat intuitive to you. Good. So that's our first introduction into graphing functions and how to manipulate them. There was a lot there, and now in the problems you're going to see more complicated examples where you do multiple things. You shift it to the left, shift it up, and invert it. You can do any combination of these things. So it's good to, look at them piecemeal first. Okay? So make sure you check out the next video for the second half of this chapter.